This is lesson 89, and it's in regards to perfect squares and square roots. We're going to start out by reviewing what a perfect square is. When you take a number and times it to itself, the answer you get is a perfect square. So 1 times 1 is 1, so 1's a perfect square. 2 times 2 is 4, so 4 is a perfect square. 3 times 3 is 9, so 9 is a perfect square. Again, 1, 4, and 9 are all perfect squares. 4 times 4 is 16. That is also a perfect square. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. And 13 times 13 is 169. So I have just reviewed with you the most common perfect squares. If you look at problem number 1 in the bucket, it has a root. What they're doing is going the opposite direction. They're giving you the perfect square and asking for what the factor is. So the square root of 1 would be 1, because 1 times 1 is 1. The square root of 4 would be 2, because 2 times 2 is 4. Square root of 9 would be 3. Square root of 100 would be 10. Again, thereafter, what number times itself is the value inside. Looking at the examples, when you're given a larger square root, it won't always be so obvious what your answer is. And there's going to be 2 ways you can approach it. The first way is to look for those perfect squares as factors. So if you look at my problem, square root of 400, I can break that down into 2 other roots. 4 times 100 is 400, and each one of those are perfect squares. I know the perfect square of 4 is 2, and I know the perfect square of 100 is 10. So that makes the perfect square of 400 20. So that's the first way you can do it. The second way is you can use the tree and figure out the prime numbers. So that would be 4 times 100, which you break down to 2 times 2. Got to keep track of those numbers. And then 10 times 10, which breaks down to 2 and 5, and 2 and 5. What I do is I put that back into the root. So I have 2 times 2 times 2 times 2 again times 5 times 5. This is where I'm getting them from. Those are the 4 2's. These are the 2 5's. Every time I have a pair, that means it's a perfect square. So a 2 comes out. There's another pair, so that's a perfect square. Another 2 comes out. Here's another pair, another perfect square. The 5 comes out. So that ends up being 4 times 5, which is 20. Now I know the second method looks like worse, but it's actually the more consistent method, and it happens to be the one that tends to be preferred by my 7th and my 8th graders. So you might want to kind of try it out a little. Number 2, same idea. We're going to do this by both methods again. Let me switch my color so you can separate the problems out. Now the first method is I need to look and see if there's a perfect square involved. So 25 is what I'm going to use. The square root of 625, I can break that down into 25 times something. I'm not quite sure what yet. So I'm going to use 25. And then let's see, every 4 would be 100. So that would be 4 times 6. And then one more. So actually it's square root of 25 times 25. Oh, I just found my answer. It's 25, isn't it? 25 times 25 is 625. Now, let's do that with the tree. If I had done that with the tree, let me pick something other than 25. Let's say I'd use 5 instead. I would have pulled the 5 out, And then I might have had to go over to the side to figure out what 625 divided by 5 is, because I honestly don't know what it is. So let me look. Goes in once, gives me 5, 12, that'd be 2, 10, 125. And then I'd break it again. So 5 again. Now 5 into 125, I'm going to go down here for that. Would go in twice. That gives me 10, 2, 5, 5 into 25, so that's 25. And then I have 5 and 5 again. Now using this method, when I put it back under the root, it's going to be 5 times 5 times 5 times 5. Every pairing is a perfect square. So what I do is I take one copy of that pairing and put it outside the brackets. So I put a 5 outside the bracket. On the second pairing, 5 again. So I end up with the 25 that way. 2 different methods again. Let's try that one more time. And I know I got quite a bit of noise on this video. The barking dog is Frances. We're outside, and she's barking at the neighbor who's trying to trim up his yard. I kind of got bored sitting inside, so I apologize for the additional noise. Now let's do this one more time. 256, honestly, right off the top of my head, I have no clue what the 2 perfect squares are that might go into that, if there even are 2 perfect squares. So what I'm going to do is go right away to the tree. And let me see. I know 2 goes into that because it's an even number. So I'm going to take over on this side 2 into 256 and see what I get. 1. All right. Then it'd be 2. That would make 5 minus 4, which would be 16. 2 into that, 128. So 2 times 128. And now that's divisible by 2. Then that would be 64. And then 64 is the same as 8 times 8. And then 8 times 8 would be 2 and 4. And 2 and 4. And then I can break my 4s down to 2 more 2s, sorry. The dog's distracting me a little bit. All right. Now I put that all under my root, of which I have a lot of 2s, don't I? So to do that, let me go ahead and clear out this right down here and put it right underneath. I do have quite a few 2s, don't I? Gonna need a big bracket. Okay, 1, 2, 3, 4, 5, 6, 7, 8 2s. Now remember, I'm looking for pairings. Let me make sure I got 8 of these. 1, 2, 3, 4, 5, 6, 7, 8. Every pairing is a 2 that comes out. Another pairing, another 2 comes out of the root. Another pairing, another 2 comes out of the root. Another pairing, another 2 comes out of the root. So, all together, that makes 4 times 4, which is 16. Now, as far as number 4 goes, it says which 2 consecutive whole numbers is the square root between? Well, for root 29, they're asking, all right, what are the 2 closest perfect squares? That would be 25 and 36. So the square root of 25 would be 5, and the square root of 36 is 6. So it's between 5 and 6. For 48, the 2 closest ones are 36 and 49. So that means it's between 6 and 7. And as far as the square root of 17, the 2 closest are 16 and 25. So it's between 16 and 25, which would mean it's between 4 and 5. Closer to 4. That's it.